All right, guys, welcome. This is the first of our distance learning geometry classes. We are starting Unit 3, which is quadrilaterals. Just to recap on what we did before the break, we had Units 1 and 2 done. So we did foundations of geometry. We did all of the different constructions. We started looking at parallel lines. We started looking at angles in parallel lines. And then we finished off with the triangle congruency. So proving that two triangles were actually congruent and then based on different criteria. So moving into the quadrilaterals unit, we're going to try this out where we're going to do the presentation digitally, see does it work, do we need to do something different. For the most part, you'll hear my voice and then the slides themselves. I will try and write on a couple of the different slides. We'll see how that goes. If my handwriting is absolutely terrible, we'll try something different. Same format as usual. Here's our objectives. Here's our types of quadrilaterals that we're going to try and cover. And we're going to do proofs about parallelograms today. So we're going to get through actually trapezoids and hopefully a little bit of parallelograms today. Essential questions for you that you should be able to answer by the end. What makes an object a quadrilateral? So how do we know it's a quadrilateral? What allows us to classify shapes? And then how do we prove that different properties of a parallelogram are going to be true? So if you are writing these things down, which I do encourage you to do, still write notes. This is just when you pause the video and take down your notes and then carry on again. So I will leave out the pauses that I would normally do in class so that the video is shorter. Okay, so when we think about trying to classify shapes, we talked about this at the beginning of the semester. Things that allow us to classify, so that is to break them down into categories based on their properties. When we think about all shapes that are out there, the first place we started was how many dimensions does the shape have? So is it a 1D shape, 2D shape, 3D shape, or 4D shape? And then we said, okay, we want to talk about in geometry so far, 1D and 2D. We'll eventually get to 3D shapes by the end of the semester. So once we're in 1D, we're talking about single dimension, so points are actually of no D, but things like lines, segments, rays, angles, all one dimensional. And then when we start talking about 2D shapes, now we start thinking about, okay, how many sides does the shape have? So if it has 3 sides, we're talking about triangles. If it has 4 sides, now we're talking about quadrilaterals, 5 sides, you're into pentagons, hexagons, and then keep going up. And then once you're into, like, say, quadrilaterals or triangles, so triangles, 3-sided shape. What are the different types of triangles? Well, we've got equilateral, all 3 sides are congruent, all 3 angles are congruent. We've got isosceles, 2 sides congruent, 2 angles congruent, or we've got scalene, where all 3 sides are different and all 3 angles are also different. We also had things like obtuse and acute triangles. We had right angle triangles. Like, there was different ways that we could classify our triangles based on their properties. And then things like, we know all triangles, the angles add up to 180 degrees. Whereas in an equilateral triangle, that is true, but also all 3 angles are 60 degrees. So we will see that the further we classify the shapes, the more complex they get, the more properties they have. So think about that as we move into our quadrilaterals unit and we start trying to look at different types of quadrilaterals. Okay, so things that we know so far. We got 4 sides, duh. Quadrilaterals have 4 sides, they also have 4 angles, and those angles add up to be 360 degrees. So those are kind of the qualifying characteristics of a quadrilateral. The different types. So we're going to be looking at, I would say, I think it's 6 different types of quadrilaterals, and we'll break a couple of them up into different versions. So we're going to have parallelograms, rhombus, or plural of that is rhombi, rectangles, squares, kites, and trapezoids. And kites and trapezoids both get subdivided again. So a kite can be a regular kite or what's called a delta kite. And then trapezoids, you can have a regular trapezoid and then also an isosceles trapezoid. So just 2 kind of versions of the same shape. All right, to give you an idea of what the final, I guess, what you're going to produce at the end of this unit, I'm going to ask you to produce posters for each of the shapes. So I usually do this anyway. You would have done this in class. But what we are going to do is for each of our 6 shapes, we're going to produce a poster for each one that will highlight what the properties are. It'll show you how to draw the diagram, and then it will give you some example questions to work through as well. So they are essentially your study guide. And this is a great way to study for different types of content. So I really like this method for when it came to history and science. My room was covered in like posters that did different points in history or different concepts from science, and I found it a very great way to learn because I was a very visual learner. So this may work really well for some of you. Some of you will just go through the exercise and be like, you know what, I'll go back to my notes or reviewing or practicing. But some of you may realize, oh, you know what, this poster thing, that's it. This is what helps me learn. So go through this with me, produce it, get your grade for it, and then, you know, if you want to keep doing it for future units, please do. So what you're gonna have to do in this one, series of posters, you can do them on paper if you have like the tools at home to do it. So hopefully you brought your drawing stuff home and you also got maybe some paper lined around, some coloring pencils, markers, whatever. And then if not, you can always do it digitally, or if you prefer to work digitally, you can do that as well. I recommend using Google Slides if you're working off your Chromebook, or if you do have access to Microsoft products. I love PowerPoint for doing design stuff like this. Other equivalent programs, you can try and do it in like a Word or a Google Docs. It's a little bit more annoying just to try and get the formatting right, but if you want to take a shot at it, please do so. Programs like Paint or like just a drawing program can work, but again, can be a little bit annoying to try and get things to come together. If you want to use a program like GeoGebra for creating your images, that would be a cool thing to do, and that kind of ties in some of that old stuff we did. So that was geogebra.org if you want to use that drawing tool. If you're doing it on paper, you're going to take pictures of your posters and submit those. So we have already submitted videos for us doing transformation. So submitting a picture should not be a big step. You can either put those on a Google document and submit the one document, or you can submit each picture as an individual file. Doing it from your phone or from your Chromebook are both acceptable ways of doing that. If you're doing it digitally, you will just simply attach the file. So if you're doing it in Google Slides or a PowerPoint, you know, maybe make each poster its own slide and then submit the file. So this is the visual of what I'm looking for. This is an example from last semester. So you've got the title of the poster up top. You've got a drawing of the diagram, and you're actually going to mark it up with the properties. So by mark it up, I mean you're going to show which angles are congruent or perpendicular. You're going to show lines that are congruent. You're going to show lines that are parallel. If there's properties with the diagonals, you want to show those as well. Some other properties that maybe you will not be able to show, but we want you to think about are things like symmetries, so rotational and linear symmetries. And then you're going to do a list of the properties of the shape. So this should be every property that goes with the shape, and then what the example of that property is in your diagram. So your diagram should have letters on all the points so that you can start referencing them in this table. So in the example here, you've got one pair of parallel lines, and we said, okay, that means AB is parallel to CD. So we show on the diagram the little arrows. So that is, you know, up top here and down below. So we said, okay, there's the visual example of those two lines being parallel. It's listed in the properties, and we've also labeled it using AB parallel to CD. So 3 different ways that's going to be shown. Once you got all those in, you're going to give me 2 example questions. So these questions you can find in your textbook. You can look up questions online. So usually if you just say property of whatever shape it is and algebraic worksheet, you'll find some sort of question about it. Look in your textbook, you'll find as well, or just make up your own. Look at the property and think, okay, what would a question look like that would use that property to solve it? So if we're saying that opposite sides are parallel, well, that sets us up nicely for maybe some alternate interior angles being congruent or same side interior angles being supplementary, and then you go solve based on that. So you need 2 of those and try and make them different from each other. So try not to use the same property twice unless it's a very limited question, and also try and challenge yourself. So you're trying to think like, what would Mr. Phelan asked me potentially in a unit test or a quiz. Like that's the standard of question I would like to see. So, you know, not just like, oh, one angle is 30 degrees, the other angle is supplementary to it. What is it? Like, it's not hard enough. You know, you're going to get asked harder questions. So this is kind of a clear, hopefully, example. You should be able to pause the video, look at this, come back to it. I will post this image as a standalone image as well in your Schoology folder. But you've got all the different things that I'm looking for up here. So the title, the diagram that's marked up, you've got the table with the properties, and you've got the space for the two examples. So I did one example just to kind of show you what I'm looking for, and then the other example I just wrote in the kind of generic what I'm looking for. If you are doing digital, try and use an equation editor. So if you're in Google Sheets, Google Docs, PowerPoint, Word, they all have equation editors built in, and that allows you to kind of do a little bit more with the math. So rather than trying to do some funky stuff with just regular keys, try and actually get the math type in there. Now, if you are working off something like a laptop, or sorry, a phone, or a more limited device, you can also do things like insert pictures. So do the math part on a piece of paper, take a picture of it, insert that into your digital poster. That's fine. You guys come up with a solution that works and still ticks all the boxes that you need to get the grade. If you're in any Microsoft product, if you hit Alt and then the += key, it will open up the equation editor for you. That does not work in Google. So if you're in a Google Sheet, Google Doc, you will have to actually go into Insert and then Equation, and it will pull it up for you. All right, so now we're actually into the content. This is where your real note-taking starts. The first shape we're looking at is called a trapezoid. This is beyond just being a general quadrilateral, this is the most basic quadrilateral we're going to see. So what you've got here are a shape where two of the sides are parallel, and it's not possible for adjacent sides to be parallel because by definition adjacent sides will touch each other. So in a quadrilateral, you have one pair of opposite sides are parallel. So that is the kind of qualifying criteria to be a trapezoid. So you'll see in both figures, we've got pairs of parallel lines. The one on the left is just a generic trapezoid. The one on the right is an isosceles trapezoid. And the only difference between them is that you have also got a pair of congruent sides. And the congruent sides are not the parallel sides. What you'll actually find out is if you had parallel and congruent sides, you would end up with a parallelogram. It's enough information to guarantee a parallelogram. So once again, properties, you've got one pair of sides are parallel. You've got, so that would mean that we've got angles that are same side interior. So we know they will add up to 180 degrees. And same thing the other side, but they will not be equal to each other in any way. So same side interior angles will be supplementary. There's nothing special about the diagonals in a trapezoid. So you're pretty much all three angles add up to 360, or all four angles add up to 360 degrees, and same side interior angles add up to 180, and you've got the pair of parallel sides. So that's it. If you do draw in diagonals, or they're given to you for some reason, don't forget you will get alternate interior angles that are congruent. So that's the only other thing to watch out for in questions about trapezoids, or hints for you to use in your examples. On the isosceles trapezoid, a couple of extra things. The diagonals are in fact also going to be congruent. So if we were to think about this, and we'll prove this in a second, that the diagonals will be congruent to one another. If you have got, let me change color quick. So if you've got this triangle up here, we know one side is congruent in both already. The top side is actually reflexive. And then another property that we will realize is that the angles on the same level, so these are called the base angles, are congruent. So these two triangles would in fact be congruent by side angle side, which means that the longer side, the diagonal part, must also be congruent. Kind of erase all my mess quick. All right, so now we also, the property I hinted at there was that the base angles are congruent, so the ones on top and bottom are going to be the same, just like an isosceles triangle. So you imagine if this were to continue up, this would have been an isosceles triangle, and we just kind of cut the top off of it. So the base angles would have still been the same, and then you get kind of these base angles the same up here as well. That's isosceles trapezoid in a nutshell. So isosceles trapezoid, more properties. Make sure you are getting all those properties down into your notes. So we've got base angles are congruent. So that's the two bottom ones, two top ones. They are congruent to each other. The same side interior angles are still supplementary. So they're still supplementary and they're also congruent to their base angle. What that also means by default, so if the two angles on the side here are supplementary, so these two are supplementary, and these two are congruent, well, by substitution, that means that the opposite angles must be supplementary. So thinking about that now, you've got a couple of additional properties in here. So base angles congruent, opposite angles supplementary, same side interior angles are still supplementary as well. And then we talked about one pair of opposite sides are congruent and one pair of opposite sides are parallel and the diagonals are congruent. So making sure you got all of those properties listed in your notes, ready to put in your poster. And here's kind of a brief summary of them and a marked up diagram for both. In terms of symmetry, the isosceles trapezoid does in fact have one line of symmetry, and that is the one going straight down the middle. Okay, so parallelograms come next. So in terms of our classification tree, a parallelogram is like an isosceles trapezoid that has more. There's more things that are true about it than just an isosceles trapezoid. So looking at the diagram here, what can you spot? So things like we've got opposite sides are parallel, and we knew this already. We kind of used previous units to start proving a lot of these things about parallelograms. So the opposite sides are parallel. They're also congruent. So looking at the markings for congruent, we're seeing like, okay, opposite sides are also congruent. On the angles, opposite angles are congruent. And then with the diagonals, so let's just kind of dig quick into what's going on here with these diagonals. So on the diagonals, we've got 4 lines here and here. So 4 hash marks, which means that the diagonal from here and here are the same. So it's been cut in half, it's been bisected. And then the same thing has happened on the other one. So the property here is that the diagonals bisect each other. Now they're not congruent to one another because the hash marks don't match. We've got a 3 hash mark and a 4 hash mark. So they are different lengths, but both sides of the diagonal are the same. So they have been bisected. So the property of a parallelogram is that the diagonals bisect each other. Nothing special in terms of where the diagonals meet the angles. We do have alternate interior angles again, which you guys knew about already, but the diagonal does not bisect the angles. That is a very special type of parallelogram when that happens, and we will get to that very soon. So to recap, 2 sets of parallel lines, opposite sides are congruent, opposite angles are congruent. The consecutive angles, so these are like the same side interior angles, they are still supplementary. And then the diagonals of the parallelogram bisect each other. That's the kind of big one that was different from an isosceles trapezoid. No lines of symmetry, but we could rotate the shape 180 degrees and it would rotate onto itself. So there's one rotational symmetry, and that would be for 180 degrees. All right, so now we're back into your favorite proofs. So in this case, if a quadrilateral is a parallelogram, then the opposite sides are congruent. So the given here is that the opposite sides are parallel, and you need to show that the opposite sides are congruent. So thinking about, okay, how do I do that? Pause the video, try it. So actually take a shot at it and see, can you prove that the opposite sides are congruent without me giving you any more information? Go for it. Okay, so we've done this proof once before, but just to kind of give you the highlight of what it's going to look like, we are going to say, all right, so opposite sides are parallel. If I were to draw in my transversal, so draw in the diagonal, I would know that this angle and this one are congruent, this one and this one are congruent by alternate interior angles, and then I would have a reflexive property in the middle. So we would have angle side angle on both of these triangles. How does that help? Well, if we can show that they are congruent by angle side angle, that would mean that the opposite sides must be congruent by CPCFC. So just to kind of give you what the actual proof, here you go. So we got the lines are parallel as our given. We said reflexive property was based on drawing in the diagonal. Now you can draw in the diagonal and you don't have to put that in your proof anywhere. That's just like you've included a line segment. So you're saying the distance from A to C is the same for both. You can visually show it or you don't have to. We have the alternate interior angles, and then we said triangles were congruent by angle side angle, and then finally the pieces of the triangle must be congruent because of CPCFC. So one of the harder proofs that we did, but we did this one a while ago when we were doing triangles being congruent. Here's another one for you. I think we've done this one already, but just in case, let's do it again. Opposite sides are congruent. Prove the opposite angles are congruent. So what do you do? Again, pause the video now, try it, and then see how it goes. All right, so let's go through this one together. So we're going to need that diagonal drawn in again. And then we've got, let's see, opposite sides are congruent. So I'm going to actually write those in. So AB, and apologies for terrible handwriting, AB congruent to CD, and BC congruent to AD. And those are my givens. So in my diagram, don't forget to mark it in. Next question would be, well, what can you say about the diagonal? So the line from AC. It is going to be congruent to itself, and that is reflexive. So I'm marking that one in. So now if we look at our two triangles, we've got side, 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 and we've got side, side, side. So these triangles are congruent by side, side, side. So triangle ABC congruent to triangle. In the corresponding place of A is going to be point C. So C, D, A, and this was a side, side, side proof. Now, final statement is to say angle B and angle D are in fact congruent. So we would say angle B congruent to angle D, and this one is also CPCFC. So it's like the last proof we did, but just a different approach. All right, last one. If a quadrilateral is a parallelogram, then the diagonals bisect each other. So can we prove that property about parallelograms now? So we're told opposite sides are parallel. Can we prove that they bisect each other? And I'm going to leave this one with you guys. I will give you a solution to it tomorrow. But basically, you want to try and show maybe that like this triangle and this triangle are congruent. Because if you can do that, then you could start showing me some CPCFC stuff to say like that the pieces must be congruent. But you take a shot at it, see can you do it. Tonight. So your turn is going to be you guys actually doing a little bit of homework for me. It's going to be page 368 in your textbook. If you happen to have a textbook at home, great. I wish I had told you to take them home because I knew this was going to happen. But you can also access them online, and I will post the PDF on Schoology as well. So if you're accessing online, go into your FCPS bookmarks. So if you click on FCPS bookmarks, you'll have a different list to me, but you should have a My HRW option, and that's the one you're going to use to access your online textbook. Make sure you're in the geometry textbook. So some of your other classes use HRW as well, or if you took algebra here, like you'll have the algebra one as well. Just make sure you're clicking on the geometry textbook, and then the unit you're looking for is Unit 3, Module 9, Lesson 1. And scroll down to page 368, you're answering questions 4 through 13. I will post a Google form where you will be able to input your answers to see, did you get them right? And that'll be our kind of tick the box, did you do your homework or not? Not based on correctness, just based on completion. So let's start small, let's get it done, and let's make sure everything's working all right. If you have any questions, please post them in the class discussion that is also in Schoology. So just to recap on our essential questions, what makes an object a quadrilateral? It's got 4 sides, angles add up to 360 degrees, and then we can start kind of going a little bit further after that in terms of our different shapes. So the more properties we add in, the further classified we get with different shapes. What allows us to classify shapes further? Properties like angles being congruent, lines being parallel, things to do with the diagonals, rotational symmetries, line symmetries, and so on. And then how do we prove properties are true? We set up a statement reason table. We start with the givens. We start adding in things that we know or we can prove based on previous statements that are true. And we build up a proof to get to our final goal. And then this is changed now to for tonight to on your own. So you have until Friday to do this. Get that bookwork submitted into the Google form. And then if you have questions, please post them on the discussion forum. And if you see other students asking questions, you're like, oh, I can answer that. Help out, throw an answer in there, and then start creating your posters. So start now, don't let it build up. You've done isosceles trapezoids and parallelograms, so you can get those 2 posters started now. All right, guys, that's me done for today. It's a 25-minute presentation or so. So you've got, it should take about 20 minutes to do the homework, plus a little bit on your posters. We're right on schedule. If you have questions, post them, message me on Remind, Schoology, send me an email. We will figure this out together. Good luck, guys, and I'll talk to you tomorrow.